What we are going to do now is we are going to do some questions. The aircraft is flying at flight level 120. Outside temperature is as per ISA standard. Calibrated airspeed is given as 200 knots. Track is given as 222 degrees magnetic. Heading is 215 degrees magnetic. Variation is 15 degrees west. All these terms are familiar to you. There is no term over here which is alien. You know, you have been introduced to all these things multiple times. Time to fly 105 nautical miles is 21 minutes. You're asked to find out wind. Okay. Now, before you do this question, let's just revise some theory. Let me take three different terms here. One is track, other is heading. If I take these two terms, what connects track and heading?
The drift.
It's a drift, right? And what is the reason? One of the major reasons for drift is?
Wind.
It's the wind. And wind has both wind velocity as well as direction. Right? We assume that the pilot knows how to navigate properly. Navigation systems are all precise. Therefore, the only reason for drift is wind in this case. In this question, what are you asked to find out? You're asked to find out wind. Right? You're asked to find out wind. So wind has two different components. You have to find out both of them. They're asking you for direction and they're also asking you for speed. Right? Now, do you have track given in the question? That's right here. The track which you intend to fly is 222 degrees magnetic. The heading is given. Yes. What else do we need to find out wind? So to understand that, we will look at something which is called as a velocity triangle. Have I explained velocity triangle to you before? No, right? Because we haven't gone through the initial part of general nav for both of you. That's why it's not there. I'll explain that to you now. We have done tons of questions on NDB and VOR now, so now you know exactly what we're doing here. So there's nothing much of introduction required here. So imagine that this is the track which I want to fly. And how is track represented? All those things, you know, it's a line with two arrows as a track, right? Now say for example, the wind is coming from here. Wind is a line with three arrows. Now, what heading am I supposed to fly to maintain this particular track?
Into the wind.
Into the wind, right? Which means I have to fly. If I want to maintain this track, I have to fly into the wind. Only then I'll be able to fly like this. Otherwise, what's going to happen? I'm just going to veer off on the track. So what I'm going to do is I'm going to take this one. This is the track here. Track. What is track? Or course, as we say. What is that?
Track is just the path traveled by the aircraft on the ground.
On the ground, exactly. If you chase along and draw a line along the aircraft's shadow, you're drawing the track of the aircraft on the ground, right? So what is the corresponding speed that we're looking at? It's on the ground, right? So it's the
ground speed.
It's the ground speed. Yes. So track goes in line with ground speed, right? Now what I will do is I'll take this. So the basic understanding is you have to fly into the wind. That's all the understanding which you need, right? And when you fly into the wind, what is this direction in which the nose is pointing called? It's called as a heading. Heading. So if I want to maintain a track for a particular wind, I have to fly a particular heading. That's the whole idea, right? If you have that idea, we can explain velocity triangle very easily. What I'm going to do is I'm going to take this wind here, and I'm going to take it like this, straight, and I'm going to place it here at the tip of this track vector. So what I'm doing is I'm just following the parallelogram law of vector addition, not parallelogram, the triangle law of vector addition, which you have probably must have studied in your school. But again, you don't have to memorize or even try to recollect it. It's not required. I'm just trying to take this wind from here, and I'm simply placing the wind here. And wind has two components. The first one is wind direction, the other is wind velocity. This is what you're asked to find out in the question. Right? Now, if I want to fly this track, for this wind, I have to fly a heading. You see how this heading forms in the direction of the resultant of these two? Triangle. So if I join these two lines, heading is a line represented by one arrow. If I want to fly this track with this wind, I have to point my aircraft in this direction. This is what is called as the heading. So this is heading. And that is in line with the actual speed of the aircraft through the air in nil wind condition, which is what is called as the TAS. So this is what is called as the velocity triangle. It involves three different velocities: the ground speed, the true airspeed, and the wind velocity. Now it looks like
So the resultant will be TAS.
will be the track. For a given wind, if I fly a particular heading, the resultant is a track. What we need ultimately is a track.
Track, yeah.
Right? So if I fly a particular heading for a given wind, I get this track. If I have a particular task, I consider the wind velocity into consideration, I will get the ground speed. That's how it works. Right? Now the beauty of this particular triangle is that if I have any four of them, I can very easily find out the rest of the two. You can do this vectorially, taking with angles and stuff, all those things, and that's going to take heaps and heaps of time. So we are doing it using your CX3. So if you go to CX3 and if you go to the wind correction tab, the wind correction tab will have all these parameters listed there. So you can see here ground speed, which is TAS. True course is this track here. This is what is a true course given there. You have the heading, which is again in true, wind direction, and wind speed. So what we are looking at.
So this can be the magnetic heading as well?
It can be magnetic. If you put magnetic, everything has to be magnetic, that's all. If you're putting true, everything has to be true. We have seen this tab before, if you remember, but that's the exact same thing. Now let's look at this particular question here. You're asked to find out what? You're asked to find out wind velocity and direction, which is nothing but one side of the velocity triangle. If I want to find this, I need everything else in the question. So let's see if I have everything in the question. What's the track in the question here?
Track is a 222.
What is the heading?
Heading is 215.
You don't have to do it like this for the exam. You just have to open the tab and start entering the values. I'm just explaining to you once just to understand how it works. 215. What else do we have? I need to find out winds, velocity, and direction. Can I find the ground speed?
We can find the ground speed.
Yes. How?
So we have the
time to fly 105 nautical miles is 21 minutes. So how will you find the ground speed here?
Speed is distance upon time.
Distance upon time. That is 105 nautical miles.
105 divided by 21 into 60.
21. So remember, this is the minutes. So I have to divide by 60. That goes up. So what is the ground speed?
300 knots.
300 knots. So now we have the ground speed also, 300 knots. What else do we need? Again, we need to find out wind velocity and direction. We need everything else. The one that we don't have now is the TAS. Right? So this is something which you have to find out now. How will you find out TAS? So what other information do we have? You're flying at flight level 120 with an outside air temperature at 120 is as per ISA standard, and you are given a CAS of 200 knots. Right? So if you want to find out TAS, which tab do you have to go on your CX3?
Just a second. How do I go?
So it is an airspeed, therefore you have to go to your airspeed tab. So you can exit your wind correction tab. What do we have there? We have true airspeed, which we want to find out. So we'll close now. You can come back. I will leave you once I answer the question. Second is outside air temperature. So how will you find this outside air temperature? What is the flight level? 120.
12,000, yeah, 120.
How will you find out? And what is the outside temperature given? It is as per ISA standard. 15 degrees Celsius mean sea level temperature, reducing at 1.9698 degrees Celsius per 1000 feet, or you can take it as 2 degrees Celsius per 1000 feet lapse rate. So find out, you can find out, you can also close and come back, find out the outside temperature at flight level 120 ISA. Alright, so how will you find the temperature, ISA temperature at flight level 120? So sea level temperature is 15 degrees Celsius minus, you can take the lapse rate as 2 degrees Celsius per 1000 feet into, what does flight level 120 mean?
12,000 feet.
That's a pressure altitude of 1 to 1,000 feet. Yes, that is, for every 1,000 feet means you can multiply it with 12. So what is the temperature?
24. 15 minus 24.
Which is minus 9 degrees Celsius. That is the temperature at 12,000 feet. Right? So we have the outside temperature now. What else do we need?
How do I enter this minus 9
I'll tell you.
in my
Don't worry.
CX3?
I'll tell you that. So TAS is there, outside temperature is there. If you go down, you have Mach number, total air temperature not required, and then you can see a CAS there, calibrate airspeed. That is already given in the question as 200 knots. Right? So let's enter these values right there. So we have to find out TAS. What's the outside air temperature? Remember, you need to double check on the unit. It should be in degrees Celsius. What is the unit given there? If it is in Fahrenheit, you have to press convert unit, change it to degrees Celsius before you enter the value. Now the question here is, it's minus 9. How will you enter minus 9? Just press 9, and towards the left bottom corner you can see a plus or minus. And if you can press that plus or minus, it will show up negative there. Or what you can do is just type in 0 minus 9, and that's going to give you minus 9 as well. It's an alternative method. And then if you can press OK, that orange question mark will turn into a green tick. And if you can tab all the way down to CAS. What is CAS? CAS is 200. So you can enter 200 CAS there. And then what comes next is P alt. What is that? Pressure altitude. Flight level 120. What is the pressure altitude? It's 1 to 1,000 feet. So you can put 12000 feet, and then when you press equal to, voila, the TAS appears straight there, all the way up to 38.61 knots. That is the true airspeed. Did you understand? Yep. Now you see, go back to velocity triangle. Now you've got TAS as 238.61 knots. Go back to wind correction tab. You have everything but the wind component. Enter all these things, press enter, and you will get the wind straight. So let's get back to our wind correction tab. Ground speed. What's the ground speed? 300. Right? Enter. What's the TAS? You can see TAS already appears there. The system remembers the TAS, and the TAS is shown up there. It's already there. That's an advantage here. True course is basically the required track. It is not necessary that you have to enter the true value, but if you enter true value, everything has to be in true, and the wind which you will be getting will be also in true. If you enter magnetic, everything has to be in magnetic, and the result also will be magnetic. So let's enter the magnetic value here. That is what is given. What is the track? The true course is nothing but your track, which is 222. So usually some of the foreign textbooks use the term course to indicate planned track. So don't get confused with it. If it is set course, it is usually the planned track, which is here. And then what is the heading that you got? 215. And you can see the wind data automatically appears there. What is the wind the speed and direction? Did you get it?
9.54.
What is that? So, okay, yeah. So what is it? How do you write it?
Wind speed is 69.54 knots.
And wind direction
is
67. Be very careful. Look at these values here. They're very close. Do not think in the opposite way. That is a common mistake which I see here, because what comes first on this tab is wind speed. What you write first is wind direction. And especially when the values are very close, chances are very high that you might write it the other way around. Don't do that. But What is the problem here? Since you have put all these as magnetic, what is this direction? This is also in magnetic. But look at the options here. The options are all in true. The wind speed is fine, 69.7 you can approximate to 70, and you can find the 70 here. And that will help you to pick up the answer. But look at the direction, it is 50. Why is it 50? Because it is true. So how will I convert this 67 degrees magnetic wind into true? And for that we have the variation of 15 degrees west that is given, right? So when you apply 15 degrees west variation, what is the meaning of degrees west variation? Your true north is magnetic north is west of true north by 15 degrees. Therefore, the magnetic value is going to be more, right? Degrees west variation, magnetic is best. So how will you find true? 67 minus 15. How much is it?
52.
Degrees true. And I have 70 not 69.54. I'll just round as 70. So what is the answer? Right.
So,
You see, this question is a very nice question because this question requires you to know about velocity triangle and use the wind correction tab. It requires you to swap to airspeed tab and find the true airspeed. It requires you to find out outside the temperature using the basic temperature conversion here, which you have studied in your MET as well, right? And it also requires you to understand the use of variation and find out the true value. So you need information from multiple platforms, bring them together to get this particular answer. So it's a very rich question, and I like these kind of questions because it has so much of one particular knowledge will not help you. You need knowledge from different parts, you see, all coming together to answer one particular question. So that is why I made you do this question.